Hello, astronomy lovers. I'm Astronomy Universe. In our journey through the cosmos, few stars captivate our gaze and imagination like Betelgeuse, that gigantic, fiery crimson bloom perched on Orion's right shoulder. Today, I'll take you on a 15-minute edge-of-your-seat odyssey, from precisely decoding the gargantuan distance and size that would engulf entire planets to the unsolved mysteries of the Great Dimming that stunned the astronomical community. From the unexpected traces of gravitational waves to the tantalizing evidence of a mysterious companion, through its astonishingly rapid spin, and finally to the predictions for the moment it will burst forth as a supernova. Questions like, is Betelgeuse really preparing to say goodbye to the Milky Way? Or, can we capture every photon, gravitational wave, and neutrino from this star? Will all be answered in this video. Betelgeuse, formerly known as Alpha Orionis, is far more than just a red supergiant twinkling at Orion's right shoulder. It is a natural astrophysical laboratory unveiling countless mysteries of massive star evolution. After years of analyzing data from the Gaia satellite, Hipparcos parallaxes, and VLBI observations, its distance from Earth now reliably falls between 400 and 600 light-years, with a central value around 643 Ni 46 Ly. Classified as a spectral type Mon-May 2 Ia Ab supergiant and varying in apparent magnitude from +0 to +1.6, Betelgeuse ranks among the most recognizable stars in the winter sky. Yet scientists are captivated not merely by its brightness, but by its colossal size. With a radius 764 times that of the Sun, if Betelgeuse occupied the Sun's place in our solar system, its surface would envelope the asteroid belt swallowing Mercury, Venus, Earth, and Mars. Its surface roils like a sea of fire, dominated by gargantuan convection cells that rise and sink in million-fold bursts, akin to solar flares multiplied to cosmic proportions. In 2023, a team at the Max Planck Institute for Astrophysics, MPA, in Garching, used 3D Kopf-of-Bold simulations calibrated against ALMA sub-millimeter imaging to show that these convective flows can mimic rapid rotation, producing a spurious velocity field of several km/s across the disk. This finding poses a crucial question. Is Betelgeuse truly spinning quickly, or is this merely an illusion born of ALMA's resolution limits? The answer will illuminate the interplay of angular momentum and any unseen companion. In the dramatic Great Dimming of late 2019, Betelgeuse's brightness plunged by over 60% between October 2019 and February 2020, prompting speculation that a supernova was imminent. Yet infrared imaging and light scattering analyses revealed that its total energy output remained steady. Instead, a dust cloud formed and temporarily obscured the star's surface following a modest drop in temperature. Detailed observations with ESO's Very Large Telescope, VLT, chronicled this entire episode, uncovering the link between convective outbursts and mass ejections that explain Betelgeuse's cosmic wink. Shortly thereafter, on January 14, 2020, the LIGO-Virgo network and later KAGR detected a gravitational wave burst labeled STU-100,000, 114 FORS emanating from the Orion region near Betelgeuse. Although no direct causal link to Betelgeuse has been confirmed, since gravitational waves typically originate in extreme events like black hole or neutron star mergers, the positional coincidence ignited intense curiosity. Could Betelgeuse be silently preparing for a cataclysmic transformation? Or was some turbulent process unfolding deep within? No conclusive proof has emerged, but that moment affirmed gravitational wave astronomy as an indispensable third messenger, alongside visible light, X-rays, and gamma rays, hinting at the hidden drama behind Orion's fiery glow. In 2024, two independent groups published on ArXiv the startling hypothesis that Betelgeuse harbors a companion star, nicknamed Beetlebuddy, based on the long secondary period, 2 110 days in its light curve, Goldberg et al. Argue for a smaller star of roughly 1.17 m 0.7 m orbiting at just 2.43 r. Radial velocity and astrometric variations corroborate this, indicating tidal interactions that spin up Betelgeuse and loft material into its outer layers, while simultaneously tightening the companion's orbit and driving it toward a merger within 10 years. This model not only accounts for anomalous brightness cycles, but also paints the portrait of a dramatic binary system mere centuries away. Support for Betelgeuse's binary nature comes from peer-reviewed articles in Astronomy Magazine and Physics.org, where similar conclusions were drawn and observers called for targeted monitoring of dust eclipse events and periodic velocity shifts for definitive proof. Consequently, Betelgeuse has evolved in our minds from a lone giant to a dynamic duo, waltzing in cosmic silence, but with epic gravitational choreography. The star's surface rotation, historically measured at 5-6 kilometers s 30-40-year spin period, remains enigmatic unless one invokes tidal spin-up from a companion. Alternatively, purely convective signals might be misinterpreted, underscoring the need for multi-wavelength ALMA campaigns with higher resolution to map multi-layer convection and to assess magnetic braking or enhancement in red supergiants. Ultimately, the pressing question remains: when will Betelgeuse explode? Stellar evolution models and studies of its bow shock in the Orion-Oboneya Association suggest tens of thousands to hundreds of thousands of years of fuel remain before core collapse into a supernova. When that day comes, Betelgeuse will flare to the brightness of a half moon, visible even in daylight, unleashing torrents of neutrinos and strong gravitational wave heralding a true multi-messenger spectacle unseen in human history. After decades of observations and countless simulations, Betelgeuse stands as a grand cosmic drama spanning millions of years, born in a dense stellar nursery, enduring crushing internal pressures, rising to cosmic prominence, and destined to fade into interstellar dust. With every new discovery, from its sudden dimming and convective maelstroms to gravitational wave hints and whispers of an unseen partner, we inch closer to deciphering the final act of this massive star. Betelgeuse not only dazzles us with the vastness of the cosmos, but also inspires endless questions. Will humanity witness its supernova finale? What other secrets lie buried beneath that dusty veil? And that, perhaps more than anything, is the star's greatest allure. Betelgeuse remains one of the most mysterious stars in our galaxy. From its immense distance and size, through its unusual dimming events, to breakthroughs in gravitational wave astronomy and its hidden companion, each new discovery only deepens our awe of the universe's diversity. Thank you for watching Astronomy Universe. If you enjoyed these exciting cosmic updates, don't forget to subscribe to the channel and share the video to help spread the love of the starry sky. See you on our next journey among the stars.